everyone, I'm Dave Aronchik, CEO of Expanso, and I'm here to talk to you about something that I think gets really hidden in a lot of our obsession with AI and ML today. That is observability in the AI data pipelines. Now, a lot of people, when they talk about observability, they think about the many excellent tools that are out there, Honeycomb and New Relic and Grafana and Loki and all these tools, these stacks that are designed to be very responsive around the way that we go and execute microservices and distributed tracing and things like that today. They are excellent. You should absolutely use them today in order to make sure your data pipelines and your AI is working properly. However, I'd like to make a case for what it means to observe your data as it is moving through your pipelines, particularly when it comes to context and enriching AI and getting good answers. And I think that level of observability is really being missed right now. So let's start with a little mini example. This is all names have been hidden to protect the innocent, but this is a real world example that we helped some customers through. You go and you ask your chatbot, which has been trained on all of your documents and Salesforce and history, contracts, and so on about the return policy for this. So you go in, you ask your chatbot, what's the return policy for this product? And the product responds, or the chatbot responds, and says 365 days, has great latency metrics, has great confidence metrics, everything is correct. Except the support product is actually, the return policy is actually 30 days. And so then you're like, well, I don't really understand what happened here. My top line numbers are green. What do I do next? So, when you think about those top line metrics, it's not just about confidence, which is a measure of how good your model is against the eval set and so on. But it's all of these things that you might be thinking about for standard microservices and other service endpoint behavior. Latency, throughput, eval, error rate, so on and so forth. These are all saying green, but the answer's still wrong. And so then the question is like, well, what do I do next? So this is where we get to the data problem. All those things we talked about, those have many years, decades of observability, history, and metrics being built in. And right now, we're entering a new world where the actual services that are providing the value are completely separated with how accurate the results are. And it is going to cause the need for a new level of observability, both as you ingest the data, you're going to have to do work on the front end as you ingest the data, but also what you get out the other side. So, touching on this, like just to lay out the scale of the problem here, we're talking about zettabytes. That's what happens beyond yottabytes, what happens beyond petabytes, what happens beyond terabytes. Like we get to zettabytes of total data being created, projects not reaching production because they're not accurate and so on. And really, one of the biggest problems is that the data is not being created in the places you'd like it to be created. We'd all love if every system in our organization used a single central data warehouse to read and write every single thing, but that's just not the way it works. You write to local files, you write to logs, you write to observability endpoints, maybe you write to external endpoints, maybe external endpoints like Salesforce or HubSpot or whatever are generating data that you're going to use. So there's lots of stuff here. And black box AI, which sits over the top of all this data, makes the problem even worse. Now, part of it is like there's a lot of challenges in rolling out data. When I went out to the internet, I went to Blue Sky and asked questions about how to actually use and track data today. I got just tons and tons of people weighing in with answers. All this is public. You can go write it down. I hosted on a public gist, and you can go check it out. Just in rolling out your AI, you run into these problems. And you probably have seen at least 3 of these this week. But then, that's just rolling out the model, which is what most observability tools are focused on today. Did this get out? Did it run? And so on. After you get the model out there and it's running, now it gets to a second question about what you do with the data to feed that model, the data to use that AI, and the data to train over time in order to make that model smarter and get feedback. And there we had even more questions and problems. And you can see just a few of them there. Now, this isn't designed to scare you. Like, it's just like there's a lot of different problems here, and trying to apply one tool, particularly tools that were set for the microservice and other distributed compute world, into this space may not be a great fit. What I like to say is, AI pipelines tend to be a combinatorial nightmare. If you think about your typical ETL process that probably all of you are doing today, you start with source, and you go through. You extract the data into a form, you transform it so that it can be properly landed in your data warehouse, and then you load it, right? This is what ETL says. It does what it says on the box. When you talk about your AI and RAG pipelines, things just get insanely complicated. The sources can come from all over. You could be merging sources, you could be aggregating sources, you could be doing all sorts of things up front as you create this. You're then also taking it and creating new data. So if I have this data coming from these various places, and then I begin to embed, that embedding is a new bit of data. It's how these two things relate to each other. And then, of course, how I get to retrieval. We toss all this into what I've begun calling the data goulash, which, is more often than not correct. And then finally, you get to your LLM, which may be trained or may be using to infer. And this is just completely nonlinear. And as a result, it makes it very, very hard if you start only over here on the right and say, well, okay, exactly what service did this come from? How do I deal with that? These are all the challenges that we face today. It's just basically impossible. So I would argue that the model is not the mystery. I think we have a known pattern for how to build these things, how to roll them out, how to monitor them as they get to production. And I think what we really miss right now is especially around the data path. So where we look tends to be the story of the drunk under the light post, where he's looking for his keys, and he's asked, why are you looking there? And he's like, well, the light is better here, even though he lost them across the street. That's what we do, right? All these things look green, but the things that actually matters is staleness, is drift, is authority, is the wrong thing reading and writing this. These things are not being tracked today in the same way that they're being tracked with our microservices and our service endpoints. And so it's, typically not a model failure that causes the problem. Typically, it is the data used to feed the model was somehow poorly shaped, somehow lacked context. In some way, it was not enough for the LLM to make a good decision. And so, while we want this to be the case, source generates response, what ends up happening is you actually have a full path, much like in your ETL, but I would argue much more complicated because many of these steps are one-way doors. You go through them, you embed or you normalize, and if you're not very diligent, you're going to lose the information that is not being cascaded through. And so with every stage being able to corrupt, I think there are three questions you need to observe for every one of these things. Where did this data come from? Is the data current? And did the shape change? And this is something that happens at each step. You have to ask these questions at each step, because if you don't, you're going to, again, get to this last step and not know, and not just ask these questions, but then write a record of actually what happened. And like I said earlier, I think there are these three big categories of where these pipelines fail silently. And the more that people can get this into their head and begin to build systems that detect for these things, the easier we're going to make debugging. And I'll show you how in just a second. Now, one thing I like to joke about is a lot of people look at this, especially folks that aren't excited about coding, and they're like, "Oh my God, this is a wall of text. This is super bad." But in a lot of ways, I think this is beautiful, right? When you look at this, it says at each stage what went wrong in this Python file. This function handed to this function, handed to this function. These were the lines it came from. This is where the memory error happened, so on and so forth. Like, all badness. Except it makes it very, very easy for me to trace through and figure out what went wrong in order for me to debug. And without these kind of data-driven stack traces in the AI world, you just run into just mystery. It's not, you're not debugging, you're doing archaeology. You know, what happened, who did it, where did it go, and worse, it begins to loop on and on and on. So now this could have happened many months ago that you made the bad decision, and then you looped on it, looped on it, looped on it. Finally, it comes up with a bad answer, and you got to go figure out, what happened. If you're just arguing about prompts, you're already way, way, way too late. So what I think is there should be a sanity check around this. Now, there are two tools that I'm going to propose here. One is completely open source, and one is our company. And in both cases, regardless of whether or not you use these tools, I just highly recommend you use these patterns. This is where we get into the tiny commercial interruption. So the first is a product. It's an open source project that I support that is completely Apache 2 MIT license. There's no commercial whatsoever, but it's a schema that people can snap to. Many folks might have heard of the term SBOM, software bill of materials. I would argue there needs to be a data bill of materials. But unlike software, which is terrific and gives you a full dependency tree, the dependency tree is often static. You pin versions and then you build your binary. What we need in data is not just here's the source where this came from, but ideally an architecture which allows you to cascade forward and say, here was the source, but the next thing is this, and the next thing is this, and the next thing is this. And then when you use it at the end, you're not just identifying the original source, but you're identifying everyone who touched it along the way. And ideally, if you get into really secure situations, you can do things like hardware backing and have signed attestation. But even if you just build that very simple provenance tool, you're going to be off to a good start. And so you can see it looks something like this. There's a full spec out there. I'm not going to bore you with all of it, but it's like, if you have this and you can say, here's the predicate, here's the origin, it came from this Salesforce knowledge article, so on and so forth, and here was the retrieval time. By adding this into the training set that you are handing to your data engine, you really transform the way that you're able to debug. And I always like it when famous people support this. Just a few weeks ago, he was talking about how Jack Dorsey, the co-founder of Twitter, was talking about how they feel that provenance is going to be one of the most significant investments that people make. And unfortunately, it's the kind of thing you have to start making now, because if you wait till next year, then that's a year's worth of data, which will have no provenance. And you'll have to, at best, some of it you'll be able to recreate. Most of it is just lost forever. So this is the project. Go use it. Then we get to my product, which is a distributed data pipeline. And the idea is what we do is make it very, very easy for as far left as you would like, including potentially on device, cross zone, cross region, cross cloud, on vehicle, whatever it is. Allow you to apply that data bill of materials, to create it right there, and then allow it to cascade forward into your existing data pipeline. So on these edge nodes that might pull from Salesforce or cloud events or external APIs or on-prem resources and so on, right there, you use an agent like ours to apply this. Don't try and apply it later, because you're going to be trying to recreate in the same way that we were running into earlier. This is our company. This is our product. We have free trials. Go try it out. Text me if you have any questions. You can write this yourself. Again, I'm not trying to talk against you using our company, but you can do these kind of things yourself. And regardless of whether or not you use us, just please do it sooner rather than later. So what this looks like is, again, let's say you have that Salesforce update and it cascades all the way forward into that bad answer on the far right. But what failed was far upstream. And so that's what we're going to demonstrate here. Like, how do I actually debug that? All right. So what we have here is a standard chat interface where we are going to investigate our data. And when I go in here and I ask this question, what is the support policy for this product? It goes and begins to ask that question. Now, like I said earlier, I have trained it to look at some bad data. And in this case, it's saying the data can be refunded within 365 days of purchase. We know that's wrong. So I'm going to query my LLM, local LLM that I've written, and say, no, you are wrong. Check again. And it's going to go off, and Moments later, nope, it's very confident, which is always the worst. How do you, what happens when your LLM really works against you? So I have a second LLM here, which I'm using to investigate data sources. So this is a completely separate one from the chat, but I'm going to say, what is the source for 365 days as my support policy? Okay. So now it's going and it's going to ask that question. When I go through and ask it, and it says, oh, I see the value 365 days, but I don't know where it came from. It was designed to look for provenance and lineage, but it doesn't have anything there. So now I'm going to switch over to a CLI. Don't freak out. This is just one little thing, and I'm going to just grab this so I don't make a mistake as I type here. Forgive me. And what I'm going to do is I'm going to go and I'm going to type this in. So this is searching across that data that I had exported previously. And I can see, here it is, right? I searched for the number 365, and I can see here in the partner feeds, in the Salesforce policy, and in the wiki page, it all is designed to say 365, which is wrong. But I don't really know where this came from. I kind of have an idea. And yeah, it says like when it was retrieved and so on. But this isn't really the lineage I'm looking for. And worse, those downstream systems that are so important to me are not available with this information. So now I'm going to go and improve this. And the way I'm going to do that is using our product, Expanso. So Expanso is a distributed data pipeline. We have a bunch of tools here which ingest data from endpoints. And what it does is, as it ingests off this, and this is the full, we have a full GUI WYSIWYG wizard pulling this open. It's really straightforward, but I'm showing you it here so that you can see how it would work under the hood. Here you can see I'm doing a bunch of quick analysis, where I'm looking for a schema evaluation. I'm making sure the data as it's being pulled in is correct. And importantly here, at the end of pulling in this data, before I write it to this output, I'm also adding the attestation information from Makoto, as I was saying earlier. So now, again, the exact same pipeline that I had earlier works great here, but now as I run it, it's going to, improve. So I'm going to say, I'm going to go and I'm going to save my changes. And when I do those changes, I'm going to paste this in here. I'm going to refresh my source so that it started running that pipeline. And now I'm going to go back to my demo here. You can see it's already picked up that the data is there. And when I say, what is the source for 365? It's going to go, it's going to ask the question again. And now that LLM does find the lineage data and is able to produce this and say, look, this is where we pulled it in. This was the source. And by the way, it's also doing this initial schema testing. I have two more pipelines here that I'm going to start running. We'll restart you. And we'll restart you. And I'm going to go back over here. Again, forgive me. I'm just copying and pasting these so I don't make a mistake while I'm typing. Copy and paste you. And I go back to my window here, and I see that both of these are correct. And so if I ask again, what is the source for 365? Off it goes. And now it's able to find the errors in all three that based on the lineage. And when I go back over here, I have it refreshing the embeds right now, which takes just a second. And when I go back to the support chat, I say, what's the support policy? And now you can see it as part of the LLM. It said anything that doesn't have lineage associated with it, I want you to exclude from the training data and then continue the training, which it did. And now what it did was it came back with only the things that had the correct lineage associated, which in this case is the 30 days. So there you go. Just by adding that lineage and some gates downstream, we're able to significantly improve the way that the system works and make debugging much, much easier. Okay, so that's a live demo. Hope you saw what we did there. So we had that bad answer. We sourced and fixed this here because it didn't have validation and it didn't have authority. And as a result, everything downstream became better, and the answer was corrected. So what does the operating model look like? Like I said, thinking about freshness, thinking about contracts, thinking about lineage is critical. Building this kind of metadata in upfront is absolutely essential if you want to build and support your pipelines over time. And what I suggest for teams, regardless of whether or not you use Makoto, the open source project, or our commercial project, you do, called Expansive, got to say my name, you got to go and build these things in, because you're just never going to build a production ready system without it. 3 things to walk away with. One, pipelines are production distributed systems. Treat them as such. Think about traceability, think about lineage, think about spans, all that good stuff. If you don't have lineage all the way back, you have no trust. Strongly recommend limiting how much data you pull in that doesn't have that lineage as part of its context. And observability is just the prerequisite. If you want good answers, yes, you need to build a good LLM. Yes, you need to have the right architecture and make sure it's responsive. But if you don't have observability over your data, you're going to be like in pain either today or tomorrow. Again, to walk away, the model is not the mystery. The data path is the mystery, and using Makoto and Expanso can help you solve that mystery.